My name is Manasa Mkabela, and I am a research associate at the University of Manitoba in the Soil Science Department. Currently, I'm working on an FHB project. The aim of the FHB project is to develop weather-based models which can be used to forecast the probability of Fusarium headblight occurring in cereal crops. We have 15 sites, 5 sites in Manitoba, 5 sites in Saskatchewan, and 5 sites in Alberta. And in all of those sites, we are growing the same varieties. We have 3 varieties of winter wheat, we have 3 varieties of spring wheat, we have 3 varieties of barley, and just 1 variety of durum. And next to the plots, we have a weather station which is recording all the weather data that we are going to use for developing the models. The weather station records air temperature, relative humidity, it records solar radiation, it also records rainfall, as well as wind speed and wind direction. At every given location, the quantity of Fusarium is actually recorded by the people who are looking after the plots. Those are the ones that go out in the field and count the number of heads that are affected by Fusarium headblight. And then from that, we'll develop an FHB index, which we are going to use. Then we're going to use the weather data to determine if there is any correlation between the weather data and the FHB index. We are also, at the end of the season, we're also going to collect the grain, and then we'll take the grain to Intertech, where they are going to grade it and also do dawn analysis, as well as Fusarium damaged kernels. And all those inputs we are going to try to relate the dawn as well as the Fusarium damaged kernels into weather variables. The sticks that you see here, we are calling them spore traps, because we want to see if the spores for the Fusarium are present here. In terms of of disease development, you need the host, which is the plant, you need also the spores, and then you need a conducive environment. So the weather station is looking after the environment, and the spore traps, we are using them to determine if the spore traps are there. So if any of those 3 things is not available, the disease is not going to happen. In other words, what I mean is that if the spores are not there, then you are not going to see the disease. Also, if the weather is not conducive for the disease, you might have the spores, you might have the host plant, but the disease is not going to happen. So the 3 things have to happen. You have to have the spores, you have to have the host, and you have to have conducive weather for the disease to happen. Yes, we have selected the 3 varieties based on susceptibility, going from the most susceptible to the least susceptible. We are also collecting the same data that we're collecting here from farmers' fields. We have about 100 to 120 farmers' fields in Manitoba, Saskatchewan, and Alberta. We have some summer students collecting exactly the same data which is being collected here. And then we are going to test the models. The models that we are going to use the data that we collect from the plots to test if they can predict what is happening in the field. So in order to do that, we need to have data from farmers' field.